So they have said me that my time is at 11:30. So are you, is your login working with MREC Academics? Actually, that login is not working for me, so that's why I'm creating my own Zoom ID and I'm sending this link to you. If any issues, you can let me know. Uh, as per timetable only, I'm sending my link. Okay. So now let us discuss the session like the unit that you are having for your mid-examination, that is with reference to unit 3, right? So in unit 3, we are going to discuss about modeling techniques. So what modeling is and what are the types of modeling techniques we have, right? So in module 3, we are going to discuss about system models. So in that models, we are going to discuss all these 5 types: context modeling, behavioral modeling, data modeling, object modeling, and structured modeling. Okay. So before going to the topic, before going in detail about them, so let us discuss why the system modeling is required and what system modeling is. So whenever a question is being asked with reference to modeling, we need to explain what system modeling is all about. Okay. So from the screen you can see that a system modeling is the process of developing abstract models of a system. Okay. So with each model presenting a different view or perspective of that system. So here basically what we will be doing is we will be drawing some pictures. Okay, pictorial representation of the system is called as this particular modeling technique. Okay, so in the pictorial representation or else a graphical representation, we will be displaying all the uh, uh, concerned uh, subparts of the system or else the abstract models of a system, so that the analyst will understand what the model is going to do. Okay, so the modeling techniques or else the system modeling helps the analyst to understand the functionality of the system. Okay, so the basic idea of modeling is to enable the users or the developers or the analysts to understand the functionality of the system. Okay, so what are the different perspectives of how we can explain about the models? Okay, so these are the 4 different types how we are going to explain the system or else explain the modeling of a system. Okay, that is external view, interaction view, structural view, and behavioral view. Okay, so here an external perspective, you will be only displaying what the model does. Okay, for example, if you take a view of the user, okay, so he doesn't need to know what are the behaviors of that particular different entities and what are the interactions that are there uh, inside the entities. Okay, so his objective is to just see what are the different parts, different objects of that particular model. Okay, so that is the external view. Okay, or external perspective. And interaction is nothing but the interaction is to understand how the system is interacting or else the different parts of the system or else the components of the system are having the interaction between them. Okay, so here a developer needs to know about how the modules are communicating among themselves, how the modules are depend dependent and interacting with themselves. Okay, so the user doesn't need to know the interaction process. Okay, so and structural, DFD, data flow, how it is moving how the flow of how the flow of data is moved into the system in the organization of the system is shown in structural perspective. Okay, and behavioral models are the models which are going to tell you the activities of the different models that we have. Okay, so the whatever the events that we have, whatever the activities that we have in a system are displayed in behavioral views. Okay, so if a question is being asked, explain in generic if they ask explain about system models, you are going to write the definition of what a system modeling is, and it is nothing but to represent a system using some graphical notation or pictorial representation. Okay, so generally the language that we use for pictorial representation of system modeling is UML. Okay, Unified Modeling Language, which you are learning in your OOAD as well as DBMS. Okay, so the different models are context models, behavioral models, data models, object models, and structure methods. From here itself, you can clearly write context. So whatever context that are there, okay, whatever activities that are there, what diagrams you are using for context and behavioral, you are going to explain those models. Okay, data flow, okay, or data models. Data models are nothing but structured methods. Okay, ER models are called as data models. Structured methods are nothing but the DFDs. So object-oriented models are class and object models. Okay, so we will discuss that in detail in the coming slides. So this is the basic introduction of what a system modeling is and what are the different types of modeling techniques involved in system models. Okay, any doubts you can ask me. Am I clear? The definition of system modeling, how we are going to represent system modeling, and why system modeling is required. See, three questions are addressed here: definition, and how you are developing system modeling, and why we need system modeling. Okay, in this slide you can see the three different questions why a system modeling is required. Okay, so one of your friend is responding that it is clear, so I am going ahead with my next class. Okay, and these are the views, different perspectives of system modeling as we have explained. Okay, so now let us see what are the different diagrams. So don't concentrate more on all the things, but the first three slides what I am showing are very important for writing any question in this particular system modeling technique. Okay, you need to know what are the different system models, why, how, and what, and what are the different views. If you want, you can remember it, it's not compulsory, but this one is very compulsory. So what are the different types of unified modeling language diagrams you will be using for system modeling? Okay, so from the slide itself, you can clearly see that we will be using activity diagrams, use case diagrams, sequence diagrams, class diagrams, and state diagrams. Okay, so for what purpose we are using it? Activity diagrams shows the activities involved in a process in the system. Okay, and use case diagrams, it shows interaction between the systems. Okay, see in the views, while we are discussing about the views, we have said external, internal, structural, and behavioral. So from this we can clearly match which diagram is for what. Okay, so here interaction, if I ask you to write about interaction, so which diagram you are going to draw? You are going to draw use case diagram. Okay, so activities, so where you are involving that activity, sequence also shows the interaction. Okay, so you are going to draw any of these two things for interaction purpose, right? So when it comes to object oriented method, or else whenever you are going to have a structure oriented method, you will be drawing the state diagrams. Okay, so here I will be telling you in detail but for this particular slide, you remember that we will be using these 5 types of UML diagrams to model the system. That is activity, use case, sequence, class diagram, and state diagrams. Okay, so that is what you need to know about this. And as your syllabus is concerned, we need to discuss about context models, right? But I am going to explain you about the data models and structured models first, so that you can easily understand the remaining models easily. Okay, so with this I am winding up my presentation until here. So now I am going to discuss about, I am having a context models also. Yes, context models we will be discussing once we complete the basic part. Okay, so let me switch over to my notes part. Yeah, so data structured analysis. Okay, so structured analysis, as we are seeing in the figure, in the models that we are having structured methods and data models. Okay, so data models will be representing using ER models, and structured methods we will be using data flow diagram. Anything you can write, right? So structured analysis, it will show it will show the data flow. Okay, so how the data is flown into the system and how they are performing it. Okay, so these are the things what we are seeing in structured analysis part. In structured analysis we will be having uh, different symbols which are involved in this DFDs. Okay, the symbol is oval shape. Okay, flow is represented using an arrow mark. Okay, I think everybody of you have seen this, right? So let us discuss a small example of the DFD. Okay, I think I'm clear with this diagram, right? So this diagram is from the label itself, you can see what this diagram is for. It is for cash withdrawal from an ATM, right? So I'm taking a use case called how you are using an ATM. I think all of you have interacted with ATM. Okay, so how you are interacting? What is the workflow of it? Okay, so how the data is being flown? Okay, just go through the image and try to understand it. So oval symbols are for the process, and this is the flow, how the flow is going on, the arrow mark, and these are the entities. Use of ATM card and account, right? So can you understand the diagram? Yes or no? Able to understand the diagram? Okay, no. Okay, one is yes and one is no. K1, K1. What you did not understand? Have you not used ATM? Is it not clear in the diagram? It is a diagram for the cash withdrawal from an ATM. What about remaining people? M7 and K1 are responding. One said no and one said yes. What about remaining students? I think around 30 members are there, right? Around 31 are there. Are you getting? Are you understanding? So this one is the basic diagram. Okay, basic modeling technique, data flow diagram. That is that comes under structured methods, right? So here, I don't know what you have understood, but I will explain you. So first of all, in order to have an ATM card, in order to access an ATM, you need to have an ATM card. So this is the primary need. So if you want an ATM card, how you will get it? You should have an account in a bank, right? So first of all, a user is the main entity. A user should approach a bank, and bank will open an account, and from that account the user will have an ATM card, right? So once this process is done, what the user is going to do, our objective is to draw cash from the ATM. So once the user got ATM, he will go to an ATM. Okay, he will enter PIN. Okay, and this PIN is being verified whether it is PIN okay or not. So once the PIN is verified, okay, so once the card is verified, okay, so once the PIN is verified, once the card is verified, automatically this user will enter some amount to the ATM. Okay, so once the PIN is okay, PIN is authorized, and the user enters the amount, that amount will be taken by the user, and that amount, whatever amount that the user is taken, that will be updated to the balance of the account. Okay, account is reflecting the balance once the user is detecting the amount, and that amount is updated to the account. Are you clear with this? No need to draw as it is. You can draw however you want, but make sure that you are writing the process, how the data is flowing. Okay, ATM card, how the ATM card have come. Okay, once the PIN is arrived, the PIN we will be entering yes or no. Okay, if it is yes, the amount will be taken, and once the amount is verified and the amount is taken, that will be updated in the account. Okay, so if the PIN is not okay, automatically this will be rejected. All this process will not be done. Yeah, that I will explain you. Don't worry about that dotted lines and these things. Generalization, realization, all these things will come once the class is, once the unit is completed. But I want to show the data flow. Just understand how the data is flowing in the system. Okay. Yeah. Right. So I think I'm clear with the flow of the diagram. DFD is nothing but data flow diagram. Everybody of you must be sure that we are just representing the data flow in a system. Okay. So next part is with ER models. So you are asking about realization techniques, generalization techniques, how it will be represented, and those things will be mentioned in this ER models. Of course, the things what we have discussed about DFD is nothing but to show you the data flow of that particular diagram. Okay. So I think I'm clear. So now I think all of you might have learned this in your DBMS, but I want to make sure just to give a brief description of ER models, because ER models comes under structured models, right? So after data models, you can clearly write about ER models. ER models are nothing but entity and relationship models. So entity is nothing but a real world object, okay, which have some attributes, right? See, for example, we have taken a student, and student will have his name, number, and all the things. Okay, is it right or wrong? Entity will have an attribute. You know how you are representing entities and attributes. How you are representing entities, using which symbol? I'm not focusing on this composite attribute, derived attribute, and single value attribute, because composite is nothing but to have more than one attribute. Derived is nothing but to get the attribute from its previous, from its higher class. Single valued attribute is nothing but to have one attribute only. That is nothing but an Aadhaar card. Okay, student details are composite attributes. For example, net salary or gross salary is from salary. So that is derived attribute. Okay. So can you tell me what is meant by uh, this? What is the symbol used for entity and an attribute? From this diagram, you can see and tell me, right? Yeah. Okay. Right. Here the rectangle symbol is for entity. As we said, that entity will have some attributes. So here employee is having some employee ID, name, address. Don't focus on primary keys and all. We are just focusing on what an entity and a relation, what an entity and attribute is, and the relations. Okay, so what these relations are. So we are going to know those relationships. Okay, one to many and many to. So what are the relationships we have? Cardinality ratio or the relationships that we have is one to one. See, if an entity is having only one to one relationship that represented as like this, if it is having one to many relationships, it will be represented in this uh, uh, one to many form, or else one to n we can write, or else we can give multiple lines, or else you can write n to 1. N to 1 is nothing but an entity is having multiple relations with an entity, right? N to n is having many to many relationships. Okay. So those are the basic models what you have already learned. So I'm skipping it fastly. So you might have you asked about just generalization, realization, and specialization techniques, right? So generalized method is nothing but to talk in a generalized way. For suppose if I talk as a bird, right? Bird is a generalized way. Okay, student is a generalized way. Okay, so because every student will have his name. So student one, student two, student three, or else there are different types of birds. Okay, so I'm not specifying to a particular person. I'm generalizing that word. Okay, so generalized is nothing but to give a statement generalizedly. Okay, so specialization. Specialization is nothing but to specify. Okay, I'm not talking a person. Person is a generalized word. If I tell a student, okay, person is a student, person is a teacher. So that means I'm specifying a particular thing that is called as a specialization. Okay, so you know that generalization is nothing but a bottom-up approach, and specialization is a top-down approach, right? Why it is called a bottom-up approach? Because we have seen the diagrams. I have shown you some examples also, right? Bottom up. This bird will be on top and pigeon, sparrow, dove will be at the bottom, right? So from this, we will go ahead with generalization. So bird will come, right? Sparrow is a bird, dove is a bird. Okay, like that bottom up approach we'll have. Okay, specialization is nothing but we'll be using top down approach, right? So this is all about specialization, generalization, and aggregation. Aggregation is nothing but it is the process which will show the relation between two entities, and those are treated as a single entity. Okay, so from this diagram, you can see all the relationships like one to many. Okay, many to many relationships. Okay, generalization we are seeing. Okay, in specific we are seeing about realization is not there. So I mean specialization is not there. Generalization we have used subjects. Okay, and from these subjects we are specializing it. Okay, specialization also you can see like theory or practical. Okay, so if we talk generalization means which comes here. Can you tell me what is generalization in this particular diagram? You should identify all the things. What is entity? What is attribute? What are the relationships? We have generalization and specialization. Can you see? Can you identify? None of you are responding. What is the specialization in this particular diagram? or generalization in this particular diagram. Subject names and subject credits. Okay, are generalized. Yes. Okay. Only one is responding. I don't know whether all are understanding it or not, but this is a generalized manner. So, if it comes as theory and practical, this is a specialized manner. Okay. So, we are aggregating all so that we can see all at particular instance. Okay. So, whenever you are being asked, write about a structured analysis, you should write about this data flow diagram. Okay, so this data model and structured model, these two things we have seen today. So for data model, what you are going to write, and structured methods, what you are going to write. In data model, you will be writing about what are the two methods, two diagrams we have discussed today. So which category it comes? In data model, you will be writing about entity relationship models, right? In structured methods, we'll be using DFDs, data flow diagrams. Okay. Yeah. Okay. So next we will discuss about the context models. Okay. So two models we have discussed today, and it is the easiest one. Object models are the easiest one. Okay. Object model diagram also I will show you. Before that, state chart. Okay. Class diagram. Yes. If you want, you can see this object oriented model. So just go through this. I will take your attendance in the meantime. Just try to understand it. I think you might have already learned C++, object-oriented programming in your previous semester. So can you identify this, the diagram that has been displayed? All of you see it. I will be back in 1 minute.